functions. We talked about them in the coordinate plane. You've seen that a sine function can be negative if the y-coordinate of a point in the coordinate plane is negative. So let's take a look. This is a graph done in a graphing program of y equals the sine of x. And what you may notice about this graph is that it repeats, that there's all sorts of repeating going on here. So if I look right here, let's call this the beginning of my sine wave. And then it goes up and comes back down and goes up. Oh, wait a minute, it looks like it might be starting over. Well, if I look back here, this looks like another beginning. Goes up, comes down, goes up. Oh, look, from here to here, and from here to here are exactly the same thing. If I cut this out and traced it over here, I'd get the same graph. So that's called periodicity. This wave is periodic, and what that means is it repeats. So the period of a wave is the length of the repeat. Length, horizontal length of the repeat in this case. So this is the horizontal distance between repeats. So the horizontal distance is measured on the x-axis from here to here. You can see, because this is nicely labeled, that the period of sine of x equals 2 pi. Now, there's another thing called the amplitude. It turns out the amplitude will be the number in front of the function. The amplitude is from the middle of the function. You can kind of see that the x-axis is the middle of this function to the top. That's the amplitude, or the middle to the bottom. Okay, so that's kind of the height of the function. The bigger the height, the stronger the wave, if it's a sound wave. Amplitude could also be measured from here to here, but it is not the bottom to the top. So the amplitude can be half of the top minus bottom. So it's the top minus the bottom. I'm sorry, top plus the bottom. Sorry, it's the distance between the top and the bottom divided by 2. So it's the top minus the bottom over 2. I was right the first time. The distance is always a subtraction. Top minus bottom over 2. Top plus bottom over 2 gives you the midline. All right, so you've got amplitude and you've got period. That's for what we've got here is a graph of this particular function. What happens if we change some numbers on that function? Well, if we go over to the next page, this function here is also a sine function, and it's y equals sine of 2x. And what you'll notice is, well, let's see, a sine wave always starts in the middle going up. So this is the beginning of a sine wave. This is the beginning of a sine wave. Look, this time I'm repeating every pi. Between here and here is pi. That's called the period of the wave. Now, from the equation, there's a way I can get that too, but I just want you to see where it is on the graph there, the distance between repeats. The other way to look at it is the different distance between any two bottoms or any two tops. This will also be 2 pi. This distance here will also be 2 pi if you measure it. Now, it's usually easiest to pick a spot on the wave that lands on a tick mark you can read, and in this case it's very easy. 0 to pi is clearly 1 cycle. So the period is pi, and what controls that is this. I'll show that in another screencast. Now, how do we control the amplitude? Well, wow, look at this one. This is bigger. This is, again, a period of pi, it looks like, from there to there. Okay, then it looks like it repeats again. But if I look at the distance from the middle to the top, or the middle to the bottom, or half the top minus the bottom, I see I get the amplitude is 3. It's not 6, it's not this to that. That's the big confusion. the function that I've graphed here is y equals 3 times the sine of 2x. This controls the amplitude, and it is the amplitude. And this number right here controls the period. The period is 2 pi over 2 in this case because of that 2. All right? So those are the basics of a sine function. Everything I've said also holds true for a cosine function, because if I wanted to draw a cosine function with the same amplitude and period, it would just be shifted pi over 2 to the, well, in this case, pi over 4 to the left. It would start here, and it would end here. And where this was at a 1, this would be at a 0. Where this is at a -1, the cosine would be a 0. Where the sine's a 1, the cosine's a 0. And it would go something like this. Well, it'd be -3. Sorry, I forgot the amplitude was 3. Instead of saying 1, I should have said 3. Now, that's a real rough drawing, but it would repeat. We'll show you that more in the next Math Teacher to Go. Thank you for joining me, and look for another Math Teacher to Go showing you how to find period and amplitude from an equation.